limit of a function. We are given a function f of x is 1 over x. Since x is in the denominator, we know that x must not be 0. So the domain of this function is negative infinity to 0 and then 0 to infinity. So 0 is excluded in the function. So we are interested to see what happens to this function when we approach to 0 from left side and right side. That means what is the limit of the function when x approaches 0 plus and then 0 minus, and then it goes to infinity, and then it goes to negative infinity. When you say 0 plus, that means we are in this side here on the right side, so approaching from right side, which is known as right hand limit. And you can see that it blows up, it goes all the way up, so it should be plus infinity. When you look at the next one, the graph goes down all the way. It is approaching from negative side, so 0 minus, that one is going to negative infinity. Other two cases, when it is approaching infinity, we can see those going all the way to 0. So this limit is 0. When you have negative infinity, also it approaches to 0. And then also you can say what happens to limit when x approaches 0, f of x, our answer is does not exist. All right. We are taking two more examples when x approaches to infinity or minus infinity. We are taking the same function. Now when you are looking for x approaches to plus infinity or minus infinity, you can just consider the higher order term, and the other terms you can ignore. The reason is very simple. If you factor out x squared, then you will see 8 over x squared, that will go to 0. This one will give you 1, and this one will give you 1 over x, that also will go to 0. So the plain idea is you can ignore the lower order terms. So then this one you can rewrite as this. Just a limit x approaches infinity, you keep your x squared and the denominator negative x squared, and they will cancel out. So then your answer is negative 1. So limit is negative 1. Now when you are doing with negative, same thing happens. Limit x approaches negative infinity, so we have x squared over negative x squared, that gives me negative 1. So let us verify this in the graphing calculator. So I just type the function. In the numerator I'm using parenthesis 8 plus x squared minus x divided by the denominator is 8 minus x squared minus x. Now let us graph it with the standard window will be fine. So let's go zoom 6. So now you can see when I'm taking x approaches infinity, so I'm interested on this side. So on this side, if you go to window again, maybe you can increase this one to say 100 right now, and then we'll trace it at say 99. Trace at 99 and see that your answer is approaching 0.9816 with the negative sign. So that means if you take more, it will approach to negative 1. That's the confirmation. Now let us look at the left side. On the left side, let me put here 100 negative and then check on the left side. So now I'm going to trace at say negative 99. You can see it is coming out negative 1 close. So that is exactly the limit at infinity. Now I'm taking two more examples, number 4 and 5. In this case we have x approaches infinity, and the term is like square root of 36x squared plus x within the radical sign minus 6x outside, and we have the same function. One x approaches infinity, another one x approaches negative infinity. We want to see what happens. If you look carefully, you see when x approaches infinity, this quantity here will be considered as 36x squared, and you can ignore this term because it's a lower order term, so you can ignore that one. Now since x approaches infinity, so our x is positive in here. So positive meaning is that will give me 6x. So 6x minus 6x, when x approaches infinity, this is actually indeterminate form like this. Infinity minus infinity is not 0. It is undefined and we don't know what it is. So then we have to do some algebraic process. So the algebraic process is straightforward. We'll multiply our numerator denominator by the conjugate. So let us do that. So I'm taking the conjugate of this term. You have a minus here, so we need to take a plus here. Now in the numerator you can see a minus b times a plus b. If you know the form, you can direct apply like a square b square. So that will give you the term in the numerator without this radical sign here, and 6x will be squared, and I'm writing what it will be. So you can see that is coming out like this. So this term we can cancel here. And then what happens finally, as we said, in the denominator you can ignore this one because you have the radical sign. So you have 36x squared will give you 6x, and another 6x makes it 12x, and in the numerator you have x. So this x cancelled out, and then your final answer is 1 over 12. So that is exactly the limit for this problem. Now we are in problem number 5. Same question, but in this case now x approaches negative infinity. So first let us check what happens. When x approaches negative infinity, this whole quantity will give me simply negative 6x. The reason is x itself is a negative number, so we need to put another negative to make it positive. If you look at here, this gives you negative 12x. So when x approaches negative infinity, this one approaches to positive infinity because we have negative 12x. So that negative, again this one will convert to positive number. So that exactly happens. So what we understand, when I have this expression here, I'm taking x approaches infinity, my result is 1 over 12, which is very close to 0.083, you can say. Close to 0.083. And the other one is going to infinity. So let us look at this in the calculator. So I type my function square root of 36x squared plus x and then minus 6x. I'm going with standard window Geom 6. But the right side, let us make it more clear on the graph. So graph roughly look like this. You can play with the window. So let us check what happens when I take little large value for x. In this case, we don't have to take that much. Let's try with x equals say 9 and see what happens. See, it's a 0.083. That exactly we have seen. See, it's approaching this. But if you look at the left side, it goes all the way up. That's why it is infinity. And we are done.